All right, we're gonna do another problem. This is seems like the successor problem to the one I just did. So it's group anagrams number 49, and I'm gonna try to implement a more methodical and strategic approach to writing my algorithm and just understanding the problem. So we're gonna be using PDAC. So I'm just gonna paste my template in. A little confused as to why it's. Wait, maybe. Why is it? Oh God. Okay, maybe I'll just. This was unexpected. Okay. Whoops. Okay. So it's gonna read the problem. And yeah, try to aim for around 30, 40, 50 minutes. And yeah, let's get started. Given an array of strings, group the anagrams together. You can return the answer in any order. Order doesn't matter. Okay. An anagram is a word or phrase formed by rearranging the letters. Okay, so we understand what an anagram is from the previous problem. So if we're looking at some of these test cases, okay, and it's the same as the other one. So always lowercase English letters. So no need to like standardize case or anything. So as far as like our requirements, this is sort of actually it'll be here. So array of strings. It looks like it can be a string can be an empty string. Array of strings of lowercase strings can be empty. Okay, they can be empty strings. I'm wondering if the input array will ever be empty as well. So can input be empty array? Array, that's just a general question I'm going to keep in mind. I would expect that to be false, right? Because it looks like, okay, so I think I can answer that myself. We're never going to get an empty array. As far as like the requirements go for our, like just generally speaking, an empty string is valid. So empty string is anagram gram of that. Okay, and then likewise, something like maybe something with 3 spaces is anagram of that. So okay. So I guess these are kind of edge cases. I'm just gonna place that here. Okay. Got that. Okay. So how do we want to approach this? I think it makes sense to I don't want to sort it. I think I want to. It seems like we have to be returning an array of arrays. So we'll just write that out. Array of arrays containing grouped anagrams. Okay. And so what makes sense as far as like a data structure here? So if I were to use like a hash or a map or something, that might make sense because we could maybe have like we could initialize some entry. Okay, so I think I understand. So I think I want to use plan to use a hash, and we don't care about order of these elements, nor does it seem to. Yeah, they say that you can return the answer in any order. So I think that relates to like both the order within the subarrays, yeah, as well as like the order of the arrays themselves in the larger array being returned. Okay. trying to think of some edge cases. I feel like this is kind of an edge case where there's just one element. So I'll just, yeah, single element input with single element. I guess just single element input. So example 3. Okay. And yeah, so they're always lowercase. I think we already identified that requirement, and we don't have to worry about order. So we can really just kind of, I think, start thinking about how we would approach this. So order doesn't matter for either the arrays or the anagrams. I guess the anagram groups or the anagrams themselves, the individual anagrams themselves. Okay. So that seems pretty good. We're planning on using a hash, so I'm thinking something it would look something like this, where like say we encounter eat, and we would check to see, okay, that isn't contained here, so I think we would want to just have like EAT, and then it would be EAT. So that's like the first iteration, right? As we're traversing this input array. So then the next one, TEA, this is an anagram to that. So we would want to then, I guess, compare this element against T. And then if they are anagrams, then we just want to add that element to that property. So this is T. Okay, and then the next one, tan. So I guess we need to compare that against, I'm wondering if it makes sense to sort these. That might be inefficient time-wise. It's NlogN, I think, for sort. And that would be, so it'd be like, I think NlogN times, well, I'm actually not sure what the complexity of that would be, but it seems like it would be kind of bad. So, okay. Yeah, I think that's something that we don't need to do. So, but I guess the problem being, like, the reason why we would want to do that is that then we could just search the hash, and that's a single operation. So if this was sorted, like let's say it was sorted alphabetically, AET, and we're looking for this sorted alphabetically. So first of all, T would be sorted alphabetically as AET. Does it have this? Does it have that key, the hash? So we're just gonna write that out. So does the hash have that key? It does. So then we could just immediately add the original unsorted string into the array that is the value for that key. So that seems like that would be potentially good. And we wouldn't have to, search through the entire. Yeah, I think this is better because, like, I think alternatively, if we don't sort the keys, like the letters in the key, and we don't sort the one that we're checking against, the hash. So for this case, like a NT, then we would have to go through every entry in the object, the hash, and check to see if the key, each specific key, is an anagram to the current element, which I think that might be slower. So I'm going to go with the approach of sorting, I think, the input string. I'm sorry, the key for the object. So I think that makes sense. Just gonna check my time. We're at 9 minutes, plenty of time. And I think this is a valid approach. It might not be efficient, but I think it's better than the alternative that I was thinking of. Unless there's another way to do it here. Yeah, I don't know. Maybe I'll play around with some other ideas down the road. Okay, so if we were to summarize this problem, we essentially just want to produce groups of anagrams and return these groups in an array. That's essentially all we're shooting to do. So yeah, let's think about some steps. Just move all that. Okay, so as far as like our steps go here, I think let's can I? Yeah, we can just type normally. Okay, so I think the first thing we want to do is maybe we want to. No, I think that's still the same. Okay. Sorry, I'm getting a little scatterbrained here. So I think the first thing we want to do is to guard for length 1 case for input. So we were thinking like this one. And like for that specific case, we would just want to return the input encased, or I guess enclosed in array literal. Okay, so that's pretty easy. I can't really think of any ways or like things we need to be concerned with when it comes to validating input type, or we don't have to worry about any sort of uppercase letters. And they specify that it's always letters, right? English letters, which I think excludes any sort of symbols, which I don't think would matter anyway in terms of derailing our approach. So basically, I think the next thing is to create hash. Maybe we'll just call this. I guess they're called objects in JavaScript. I'm thinking Ruby. Create object and name it named groups. Okay, and traverse input array of strings. So then for each string, we want to sort in ascending ASCII. So that's the specific string element. So like eat would be converted, or would be transformed into AET, and then check to see. We're essentially going to check to see if our if the sorted string is a key in groups. Okay, so check if sorted string is a key in groups. If it is a key, then we simply want to push the unsorted, so I guess push original string into the array for that key's, I guess push original string into the array which is that key's value, associated value. Okay. Otherwise, we just want to create, create property on object on groups, and that just looks like groups sorted string is equal to this array value with the original string as its first element at the 0th index, or the index 0. Okay, so then once we have that, we simply want to get keys, get vals from groups and return this. Turn this array of arrays. Okay. So if we were to like walk through this with like one of the test cases, maybe we can think. So for this test case, we're returning early with the input array enclosed in an array literal, which seems like the right approach. It's here. And for this one, okay, so if it's an empty string, I think this. Okay, so I'm wondering if that's valid. If I can, because like I obviously don't want to sort this. I'm wondering if that would even. It might be fine. It might not. Okay. Also, I just want to check something real quick. Let's go sort. Okay. Yeah. Just want to check something. So do I want to do that for every single one? I think I might have to. For each string. So essentially we have to like kind of convert to array, then sort in ascending ASCII, and then convert back to string. I don't like that, but I guess that's our current approach. Okay, 17 minutes. All right, so for this test case, we are creating the object, traversing the input array of strings, and so for this first element, we're transforming it into an array of characters, sorting those characters in ascending ASCII order, and then returning reconsolidating those characters into a string with just like join. So then at the end that would be AET, and we're going to check to see in our object groups if there's a key with that moniker. There is not, so then we would populate it. And so that would be evaluating here. We're creating that property on the object. Okay, so that just looks like that. And moving to the next one, it's the same situation. So we would add that string, that original string, to the array. So it would look like this would look like AET, and then eat and T so far, and so on. Okay. Okay, so I guess, yeah, we just need to like also write out the like if it's do I even I'm not even sure if I need to like check to see if it's an anagram here. Yeah, I don't think I do, like, because this is already doing it for me with the like if they're not the same string after being sorted, then they're not anagrams. Okay, this feels good. I'm gonna write some code. So that's just that first guard clause up here. And then we want to create the object. So do groups. It's an empty object. And I wonder why this is. Okay. Here we are. So now we're traversing the input array. So yeah, for each would be fine. So for each word, we want to perform the following operations. So for each string, convert to an array. So this is going to be const sorted word. Yeah, so sorted word, and then word split by empty white space, and then sort A, B, and we want it in ascending order. So I think, well, I don't think it matters the direction that we sort it, so long as it's standardized for all of the entries. So do that, and then we want to just join back together. Okay, so we have our sorted word. This is probably really bad time-wise. Okay, done that, and now we need to check to see if the sorted string is a key in groups. So if groups sorted word, it exists. I want to push the original string into the array, which is that key's associated value. So to groups sorted word, push word, else. So it's not a property on that object. We need to create the property. So the groups sorted word, and then initialize that to an array containing the word itself. Okay. And I think after all of this, we just want to return the values from this groups object. Okay. This, I'm not sure if this is right. Let's see. Word split sorted word, runtime error, unexpected identifier, so a syntax error, const sorted word, a minus b join. Oh, whoops. Okay. It might time out. Wrong answer. Because, oh. Okay. Expected was that. What if we just return groups? I want to see, I mean, it looks like it's creating a property for each one, even though we are sorting it. Okay, so we're expecting to see an object with, I guess, six elements. Oh. So it's saying line, wait. Okay, let's step back for a second. Let's just log out what sorted word is here. So ET. Okay. So that obviously like isn't the expected behavior that we were looking for. So I don't know what this, it looks like C++ syntax right there, or some, yeah. Okay. let's think about this. So why is this not sorting the word? Right? It should. Huh. Um. Hmm. Okay. So that's actually what we wanted to see. So I guess the callback function I passed to sort was leading us astray. So now we should be seeing the correct groups. Obviously this isn't gonna be like the result we're looking for, but we go like here, object, values. Okay. So I mean it's passing that test case. Let's see how we're doing as far as the other test cases go. I mean, we're passing. It's very slow, but it's looking great memory-wise. So, okay, that was weird. I guess I don't understand everything about sort. So this is like definitely a revealing situation. Yeah, I mean, it makes sense why it's really, really slow because we've got this for loop here, or it's just a for each, so we're touching everything. So touching every element. So that's just log n, or I'm sorry, it's just O of n at this point, but we're doing this sort operation, which I think like here, this is like the sorting implementation for the sort method. I think is just n log n or something. So it's like log n times n log n, which is pretty slow, but it passed all the test cases. So yeah, that was group anagrams, Leetcode medium. Revealed something that I was unfamiliar with the sort method, which is something that I think I'm very glad that I came across this so that I can not make the mistake in the future. I think what I was thinking was the way I would use sort if it was like numbers, like integers or something. And I guess I wasn't as familiar with sorting strings. I thought I needed to pass that callback function, but I was wrong. So yeah, this was fun. 27 minutes, so doing all right time wise. And yeah, I hope you enjoyed some of this. I'm gonna end it, but thanks for watching. Peace.